Normandy, June 6th, 1944, 4:05 a.m. A glider made of plywood and canvas cuts through the darkness above German-occupied France. Inside, 13 men sit rigid, helmets in laps, some vomiting into their steel pots. Between them, lashed to the wooden floor with steel cables, sits a vehicle that 4 years earlier didn't exist. It weighs 2,450 pounds. It has 60 horsepower, 4 cylinders, 4-wheel drive. It can ford a river, climb a 60-degree slope, carry 5 soldiers, mount a 50 caliber machine gun, serve as an ambulance, tow a 75mm howitzer, and operate for months of continuous combat without breaking down. The glider hits the ground hard, wood splinters, canvas tears, the nose section swings upward, and in 30 seconds the men unload that vehicle and disappear into the hedgerows of France. The Jeep. By this moment, sunrise on D-Day, there are roughly 15,000 of these machines in England, waiting to cross the Channel. More will arrive in gliders. Others will roar off landing craft onto Omaha and Utah beaches. Some will be fitted with machine guns. Others will carry radios. Still others will haul ammunition, water, wounded men, or generals planning the next move. But 4 years earlier, this machine didn't exist. Not even as a concept. This is the story of how America took 49 days, 3 desperate companies, and 1 impossible demand from the US Army, and built the vehicle that would help win World War II. A war that would produce over 647,000 of these machines. A war that would see Jeeps in the deserts of North Africa, the jungles of New Guinea, the mountains of Italy, and the frozen forests of the Ardennes. This is the story of those 2,000 parts, and how they changed everything. July 11th, 1940. Across Europe, the news is catastrophic. France has fallen. The British Expeditionary Force has evacuated from Dunkirk, leaving behind thousands of vehicles. Britain stands alone. The Blitzkrieg, lightning war, has revealed something terrifying. Modern warfare moves at the speed of internal combustion engines. German forces have Kübelwagens and standardized military vehicles developed over years of preparation. The Wehrmacht learned from a dedicated motorization program that began in 1933. America, by contrast, is caught flat-footed. The US Army still relies heavily on horses, motorcycles with sidecars, and a hodgepodge of civilian trucks converted for military use. Some units still use modified vehicles left over from World War I. The US Army's Quartermaster Corps knows what's coming. War is no longer a question of if, but when. So on that July morning, they send technical specifications to 135 American automotive manufacturers. The request is specific and, to most who read it, absurd. The Army wants a quarter-ton, 4-wheel drive reconnaissance vehicle. It must seat 3, carry a crew and equipment, have a wheelbase not exceeding 80 inches, be capable of mounting a machine gun, ford water up to the hood, climb extreme slopes, feature a fold-down windshield for reduced profile, maximum height 36 inches to the top of the steering wheel. And the vehicle must weigh no more than 1,300 pounds. The timeline is equally absurd. Companies have 11 days to submit detailed bids with complete technical specifications. 49 days to deliver a working prototype to the Army testing facility at Camp Holabird, Maryland. And 75 days to produce 70 test vehicles for field evaluation. To understand how impossible this is, consider that in 1940, designing and building a single prototype vehicle typically took 18 to 24 months. The Army is asking for complete working prototypes in less than 7 weeks. Of the 135 companies that receive the specifications, 132 don't respond at all. The timeline isn't just tight, it's impossible. But 3 companies read those specifications and see something different. They see German tanks rolling through the Ardennes. They see the Luftwaffe over London. They see what's coming for America, whether America wants to see it or not. American Bantam Car Company of Butler, Pennsylvania. Willys Overland Motors of Toledo, Ohio. And Ford Motor Company of Dearborn, Michigan. Each would play a crucial role in creating the Jeep. But only one would take the first, impossible step. American Bantam is dying. They're a small company in Butler, Pennsylvania, about 35 miles north of Pittsburgh. They make tiny economy cars, cute little vehicles that sell to people who can't afford real automobiles. Think of them as the discount option in the American automotive market. By July 1940, the company employs just 300 workers, and half expect layoff notices any day. The company is months from bankruptcy. They haven't posted a profit in years. Then that telegram arrives. The reaction at Bantam is mixed. The company's sales manager, Frank Fenn, sees opportunity. The chief engineer, Harold Christ, sees an impossible deadline. Christ is an experienced automotive engineer who had worked at Stutz Motor Company. He knows vehicles, and he knows 49 days is not enough time. You can't design a transmission system in 49 days. You can't source 2,000 components in 49 days. You can't test and revise in 49 days. You certainly can't build something that doesn't exist in 49 days. But Bantam is dead either way. If they do nothing, the company folds by Christmas. If they try and fail, the company still folds. But at least they tried. Christ and Fenn begin preliminary work on the design, but they need help. Fenn makes a desperate call to Karl Probst, a freelance automotive designer in Detroit. Probst is 56 years old, highly talented, and between contracts. He'd worked for Studebaker, Federal, and other automotive companies over his long career. When Fenn explains the Army's requirements and the 49-day deadline, Probst's first response is simple: no. The timeline is impossible. It can't be done. No one in the industry could do it. But then the Army itself contacts Probst. An officer explains the situation. They need this vehicle. War is coming. The timeline is real, non-negotiable. And they're asking him personally because Bantam is the only company that seems willing to try. Probst doesn't sleep that night, thinking it over. The next morning he agrees, for a fee of just $200 total. On July 17th, 1940, Karl Probst arrives in Butler, Pennsylvania. He has 5 days to complete detailed technical drawings and specifications. Bantam has already done some preliminary work, but they need Probst's expertise to turn concepts into a buildable vehicle. He begins by throwing out the idea of designing from scratch. There's no time. Instead, he works with the Bantam team to raid every vehicle design they've ever studied. They pull the best pieces, the lightest parts, the toughest components from dozens of existing vehicles. They're not creating elegance. They're creating something that might actually work. Probst works around the clock. He sleeps in 30-minute intervals. Harold Christ and the Bantam engineering team feed him coffee, technical specifications, and component catalogues. They identify off-the-shelf parts that can be modified, a Spicer four-wheel drive transmission system, modified axles from existing vehicles, an engine from Continental Motors. The weight requirement, 1,300 pounds, is immediately apparent as impossible. Every necessary component adds weight. Probst makes a calculation. Better to deliver a vehicle that works and is overweight than to meet an arbitrary limit and deliver something that breaks. Working together, Probst and the Bantam team complete the technical drawings. On July 22nd, 1940, Bantam submits their bid to the U.S. Army. They're the only company to provide complete technical drawings, the only company committing to the 49-day deadline, the only company crazy enough to try. They win the contract. The bid price, $738.74 per vehicle. Now comes the harder part, actually building it. What happens next is one of the most extraordinary feats of industrial coordination in American history, and almost nobody remembers it. Bantam's factory in Butler becomes a 24-hour operation. Workers machine parts around the clock. The company calls in every favor, every debt, every handshake deal they've ever made. Suppliers in Pittsburgh provide steel on credit, betting on a company that's nearly bankrupt. Machine shops in Cleveland cancel other jobs to fabricate custom parts for a vehicle they've never seen. A tire manufacturer in Akron produces custom 16-inch tires on speculation. Continental Motors in Detroit agrees to modify one of their small engines to meet the power requirements. Karl Probst and Harold Christ supervise every weld, every fitting. The vehicle grows heavier with each necessary component. The 1,300-pound limit is abandoned. The prototype weighs closer to 1,850 pounds. But it's functional. The first hand-built prototype is completed in early September 1940. It's unpainted, raw, with exposed welds and minimal finishing. It looks strange, boxy, stubby, almost toy-like. The body is angular because curves require expensive die stamping, and there's no time or money for that. The windshield folds down flat against the hood. The seats are minimal. There's no spare tire, weight savings, no doors, more weight savings. It's ugly, it's crude, but it's done. On September 21st, 1940, Harold Christ and a test driver climb into the prototype, essentially untested, and begin driving from Butler, Pennsylvania to Camp Holabird, Maryland, the Army's vehicle testing facility outside Baltimore. The distance, roughly 250 miles. The vehicle has no registration, no license plates. They're driving an unproven military prototype on public roads, praying it doesn't break down. It doesn't. They arrive at Camp Holabird at 4:30 p.m. on September the 23rd, 1940, half an hour before the deadline. The vehicle is officially named the Pilot Model, but soldiers at the test site immediately start calling it the Blitz Buggy, a reference to the Nazi Luftwaffe's Blitz attacks on London happening at that very moment. Others call it Old Number 1. Later, someone will start calling it a Jeep, though the origin of that name is disputed. Some claim it's a slurring of GP, General Purpose. Others say it comes from Eugene the Jeep, a character from the Popeye comic strip, a creature that could go anywhere and do anything. The name sticks. The Army tests the prototype immediately. For the next 30 days, they push the little vehicle to destruction. Rough terrain, mud pits, steep hills, water crossings, loading it far beyond its rated capacity. It keeps running. Here's where the story takes a turn that would haunt American Bantam forever. The Army is impressed with the prototype. It works. It exceeds expectations. But there's a problem. Bantam is a tiny company on the edge of bankruptcy. Even if the vehicle is perfect, Bantam doesn't have the production capacity to build tens of thousands of them. They don't have the factory space, the workforce, or the financial resources to fulfill a major wartime contract. The Army makes a decision that, from a military standpoint, is logical. From Bantam's standpoint, it's devastating. In October 1940, the Army invites Willys Overland Motors and Ford Motor Company to examine the Bantam prototype and submit their own designs. The Army provides them with detailed technical specifications, including blueprints and engineering drawings based on Bantam's work. The government's position: since they paid for the development, they own the design. It's government property, free to share. Bantam protests, but there's no time for legal battles. War is coming, possibly within months. The military needs vehicles, and they need them by the hundreds of thousands. Sentiment and fairness are luxuries the country can't afford. Willys and Ford get to work. But they don't start from scratch. They start with the specifications and design principles proven by Bantam's prototype. By November 1940, all three companies have prototypes ready for testing. November 1940. 3 vehicles arrive at Camp Holabird for side-by-side testing. American Bantam's revised model, the BRC-60, Bantam Reconnaissance Car, Contract 60, later revised to the BRC-40 after further modifications. It's the lightest of the 3, best fuel economy, excellent suspension, nimble and quick. Willys Overland's entry, officially called the Quad, named for its 4-wheel drive system. Delivered on November 13th, 1940, 75 days after receiving the contract, not the 49 days Bantam managed. It's heavier than Bantam's vehicle, coming in at around 2,450 pounds. But it has something crucial, a more powerful engine. Ford's entry, the Pygmy. Delivered on November 23rd, 1940, 10 days after Willys. It features a flat-panel body design that's easier to mass-produce. The hood is flat. The fenders are simplified. Everything about Ford's design screams mass-production efficiency. All 3 vehicles are put through rigorous testing, durability trials, obstacle courses, endurance runs, load testing, water fording, slope climbing. Each vehicle has strengths. Each has weaknesses. Bantam's is lightest and most agile, with the best fuel economy. But it uses a modified Continental engine that, while reliable, produces only about 45 horsepower. In testing, it struggles with some of the heavier loads. Ford's has the best body design for manufacturing. The flat panels can be stamped quickly and cheaply, but the engine, also from Continental, suffers the same power limitations as Bantam's. Willys' Quad is heavier and uses more fuel, but the engine, designed by Willys' chief engineer, Barney Roos, is a revelation. Barney Roos never intended to build a war machine. As chief engineer at Willys Overland, Roos had spent the late 1930s developing economical engines for civilian vehicles. The company was struggling financially. They'd nearly gone bankrupt in the Depression and needed efficient, cheap-to-produce engines. One of his creations was designated the L-134, an inline 4-cylinder engine, flathead design with side valves. Displacement, 134.2 cubic inches. Bore and stroke 3.125 inches by 4.38 inches. Compression ratio 6.48 to 1. It produced 60 horsepower at 4,000 RPM. Not impressive by 1940 standards. But soldiers who tested the Willys Quad came back raving about the engine. It had torque, 105 pound-feet at just 2,000 RPM, low-end pulling power. The ability to climb steep grades, ford deep water, and haul heavy loads without complaint. Roos had nicknamed it the Go Devil. The name was meant to be tongue-in-cheek, but it stuck. The Army tested all three prototypes through brutal conditions over the winter of 1940 to 1941. Bantam's vehicle was excellent. Ford's was well designed. But Willys's engine was the most powerful and, crucially, the most reliable under sustained heavy use. There was another factor: production capacity. Bantam's small factory in Butler could maybe produce a few thousand vehicles at most. Ford could produce hundreds of thousands. Willys, while not as large as Ford, had significant manufacturing capacity and experience with four-wheel drive systems. In July 1941, the War Department made a decision that would define the vehicle for the rest of the war. They would standardize on a single design, take the best features from all three prototypes: Bantam's lightweight and excellent Spicer transmission and transfer case, Willys' Go Devil engine and robust chassis, Ford's simplified body design with the flat hood and easy-to-stamp panels. Create one vehicle, one standard, capable of being produced by multiple manufacturers with completely interchangeable parts. Willys Overland won the primary production contract for 16,000 vehicles at $738.74 per unit. The standardized model was designated the Willys MB, M for military, B for the second contract revision. The weight limit, originally 1,300 pounds, was officially raised to 2,160 pounds. The final production vehicles would come in at 2,450 pounds, fully equipped. Production began in earnest in late 1941. Then, on December 7th, 1941, Japan attacked Pearl Harbor. America entered World War II, and the Jeep went from an experimental vehicle to a critical war necessity overnight. By October 1941, before Pearl Harbor, it became clear that Willys alone couldn't keep up with demand. The military wanted thousands of vehicles per month. Willys' factories in Toledo were running at capacity, but it wasn't enough. Ford was brought in to produce identical vehicles under license. The Ford version was designated GPW. G stood for a government contract vehicle with an 80-inch wheelbase. P designated the 80-inch wheelbase specification. W meant Willys design. Ford, being Ford, made one small change. They stamped every single part, including individual nuts and bolts, with an F. They weren't about to let anyone forget their contribution. The production numbers are staggering. From fewer than 100 Jeeps produced in 1940, production jumped to approximately 8,600 in 1941. By 1942, nearly 178,000 Jeeps. In 1943, over 180,000. In 1944, over 182,000. In 1945, before production was reduced after VE Day, over 67,000. At peak production, a Jeep rolled off the assembly line every 2 minutes at some facilities. During the highest demand periods, every 90 seconds. Ford decentralized production across multiple plants: the massive River Rouge complex in Dearborn, Louisville, Kentucky, Dallas, Texas, Chester, Pennsylvania, Richmond, California. The goal was geographic distribution. If one factory was bombed or sabotaged, others would continue production. Willys concentrated production in Toledo, but expanded facilities rapidly. The assembly process became ruthlessly efficient. The one-piece body tub, stamped from a single sheet of steel, was lowered onto a rolling chassis already fitted with axles and suspension. The engine and transmission were installed as a single unit, electrical systems connected, wheels mounted, seats installed, windshield fitted, canvas top and side curtains added, rifle brackets attached, jerry can holder bolted to the rear, toolkit secured, from start to finish, measured in hours, not days. Workers, many of them women, as men shipped overseas, assembled approximately 2,000 individual parts into each vehicle. 2,000 parts, 90 seconds between completed vehicles. By war's end, the numbers tell the story. Willys produced 363,000 MB models. Ford produced 280,000 GPW models. Total standardized Willys MB/Ford GPU production, 643,000 vehicles. Add in the earlier Bantam, Willys Quad, and Ford Pygmy prototypes, and the total number of Jeeps produced during World War II reaches approximately 647,925. Over 180,000 were shipped to Allied countries under the Lend-Lease program. Britain received tens of thousands. The Soviet Union received over 50,000. Canada, France, and Free Polish forces all received Jeeps. Some German soldiers, encountering American forces for the first time in North Africa, thought every American soldier had been issued his own personal Jeep. They weren't entirely wrong about the ratio. Let's talk about what makes this machine work. The standardized Willys MB and Ford GPW are mechanically identical. Length, 132 inches, just over 11 feet. Width, 62 inches. Height, with the windshield up, 69 inches. With the windshield folded down, about 52 inches. Wheelbase, exactly 80 inches. Weight fully equipped, 2,450 pounds. The heart of the machine, the L134 Go Devil engine. 4 cylinders. Flathead design with side valves mounted beside the cylinders rather than overhead. 134.2 cubic inches of displacement. Bore, 3.125 inches. Stroke, 4.38 inches. Compression ratio, 6.48 to 1. Output, 60 horsepower at 4,000 RPM. Torque, 105 pound-feet at 2,000 RPM. Not powerful by modern standards. But in 1941, paired with a vehicle weighing less than 2,500 pounds, it's enough. Top speed on flat ground, 65 miles per hour, though soldiers rarely push it past 45 in combat conditions. The transmission, T84, 3-speed manual with reverse. Gear ratios optimized for pulling power rather than speed. The transfer case allows switching between 2-wheel drive, rear wheels only for road driving, and 4-wheel drive for off-road. Low and high range give 8 effective gears forward, 2 in reverse. The axles, Dana Spicer Model 25 in front, Model 23 in rear, both with 4.88 to 1 gear ratios for pulling power over speed. The suspension, semi-elliptical leaf, springs front and rear. Simple, durable, repairable in the field with basic tools. Ground clearance, 8.75 inches under the axles, enough to clear obstacles that would stop most vehicles. Brakes, hydraulic drums on all four wheels, simple, effective, maintainable. Fuel capacity, 15 gallons in a single tank mounted under the driver's seat. Range under ideal conditions, approximately 240 miles. In combat, with constant idling, rough terrain, and heavy loads, closer to 180 miles. Fuel consumption, roughly 16 miles per gallon on roads, less off-road. Electrical system, 6 volt. Battery mounted under the passenger seat. Headlights with blackout mode for night operations. Waterproofed connections for fording rivers. Tires, 6.00 by 16. Non-directional tread pattern. Soldiers carry at least one spare, usually 2. The body, all steel construction. The main tub is stamped from a single sheet, welded at the corners. Fold-down windshield with a latch system. Removable canvas top and side curtains with isinglass windows. Removable doors. Most soldiers remove them for easy exit. 3 seats. Driver, front passenger, rear bench. The rear bench can be removed for cargo or converted into stretcher racks for wounded men. Official payload capacity, 800 pounds. In practice, soldiers regularly load 1,200 to 1,500 pounds. The Jeep carries nearly twice its rated capacity and keeps going. And here's the genius of the design. Every single component is engineered for field repair. No special tools required beyond what a soldier carries in the toolkit. The engine can be torn down and rebuilt with basic wrenches. Parts are completely interchangeable between Willys MB and Ford GPW vehicles. If one Jeep is destroyed, you can cannibalize it for parts to keep 3 others running. The Go Devil engine specifically uses a rough cast crankshaft rather than precision machined. Why? Because the official expected combat lifespan is about 3 months. Why waste time and materials on precision machining for an engine that might be destroyed in 90 days? Except many of these engines last for years. Some Go Devil engines are still running today, 80 years later. November 8th, 1942. Operation Torch. American and British forces land on the coasts of Morocco and Algeria. The Jeep faces its first major combat test in the deserts of North Africa. Daytime temperatures exceed 120 degrees Fahrenheit. The sand is fine, powdery, and gets into everything. Engines, transmissions, bearings, carburetors. Dust clogs air filters within hours. Soldiers learn to wrap filters in cloth, to change oil constantly, to keep Jeeps running in conditions that destroy other vehicles. The Jeep survives. British forces, initially skeptical of American equipment. They have their own reconnaissance vehicles and aren't impressed by American inexperience. Become converts after a few weeks. The Jeep outperforms British vehicles in speed, reliability, and versatility. It's lighter, faster, and breaks down less frequently. More importantly, when it does break, it can be fixed quickly. British mechanics appreciate the simplicity. 4 cylinders, basic transmission, no complicated systems. You can tear down a Jeep engine in an hour and have it running again in 2. German and Italian forces quickly learn to target Jeeps. Not necessarily because they're particularly dangerous, though armed Jeeps are, but because capturing one intact is a prize. Africa Corps commanders want Jeeps for their own reconnaissance use. They're faster and more reliable than the Kübelwagen. There are reports that Field Marshal Erwin Rommel himself used captured Jeeps during the North African campaign, though these accounts are difficult to verify with certainty. The British Special Air Service, SAS, begins experimenting with heavily armed Jeeps for deep desert raids behind enemy lines. They mount twin or triple .30 caliber Browning machine guns, sometimes .50 caliber M2s. They load Jeeps with ammunition, fuel, water, and explosives, then drive hundreds of miles into the desert to strike Axis airfields, supply depots, and communication lines. The long-range desert group does the same. These bristling, overloaded Jeeps, carrying 3 times their rated capacity, armed with enough firepower to destroy a company, become terror weapons. They appear out of the desert at dawn, destroy everything in sight, and vanish before reinforcements arrive. By the time the North Africa campaign ends in May 1943, the Jeep has proven itself. It's not perfect. The open design offers no protection, and soldiers are vulnerable to small arms fire and artillery fragments. But it goes anywhere, hauls anything, and keeps running. July 1943, Operation Husky. Allied forces invade Sicily. The terrain shifts from desert to mountains, narrow roads, steep grades, villages with streets built for donkeys and handcarts, not vehicles. The Jeep adapts. Its short 80-inch wheelbase allows incredibly tight turns. Soldiers discover they can navigate streets that stop larger trucks. The four-wheel drive and low-range gearing allow climbing grades that seem impossible, 30, 40, sometimes 50-degree slopes. In the mountains of Italy, Jeeps become pack animals. They haul ammunition up mountain trails to forward positions. They bring down wounded men from aid stations that can't be reached by larger ambulances. They tow 75mm pack howitzers and 37mm anti-tank guns up trails where horses struggle. During the Anzio landings in January 1944, Jeeps drive off landing craft directly onto the beaches. Some sink in soft sand, but most make it. Within hours, the beachhead is crisscrossed with Jeeps, carrying supplies forward, bringing wounded back, shuttling officers between command posts. The Germans learn to respect the Jeep's versatility. Wehrmacht reports note that American units have exceptional mobility due to the widespread availability of light reconnaissance vehicles. German intelligence estimates, incorrectly, that the US Army has over 1 million Jeeps. The actual number is closer to 640,000, but the perception speaks to how ubiquitous the vehicle seems. June 6th, 1944. The invasion of Normandy, the largest amphibious assault in history. Jeeps are everywhere. Some are loaded onto gliders, disassembled or with minimal assembly, secured with cargo straps, and flown over the English Channel in the pre-dawn darkness. When the gliders land, often crash behind German lines. Airborne troops unload the Jeeps and use them for reconnaissance and supply runs in the Norman hedgerows. Others drive off landing craft at Omaha, Utah, Gold, Juneau, and Sword beaches. The waterproofing isn't perfect, and many engines flood when waves crash over the hoods. But soldiers have learned tricks. Seal the distributor with grease, extend the exhaust with a pipe, wrap electrical connections in rubber. Most Jeeps make it off the beaches running. Within 24 hours of the invasion, thousands of Jeeps are operating in Normandy. General Dwight D. Eisenhower uses a Jeep as his personal transport during visits to the front. Photographs show him standing in vehicles, surveying operations. After the war, Eisenhower would praise the Jeep's contribution to Allied victory, though the exact quotes attributed to him vary, and some may be apocryphal. The hedgerow fighting reveals a deadly German tactic: wires strung across roads at neck height, designed to decapitate drivers and passengers in open vehicles. American soldiers weld vertical steel bars, quickly nicknamed rhino horns, or hedgerow cutters, to the front bumpers of Jeeps. The bars catch the wires and cut them before they reach the occupants. As Allied forces break out from Normandy and race across France, the Jeep becomes the symbol of American mobility. French civilians see Jeeps as symbols of liberation, small, rugged vehicles carrying soldiers who will free their country. In Paris, after the liberation in August 1944, civilians mob Jeeps, climb on them, kiss the drivers. The war in the Pacific presents different challenges: jungles, islands, coral atolls, mud that swallows vehicles whole, humidity that rusts metal in weeks. The Jeep adapts again. At Guadalcanal, Jeeps haul supplies through jungle trails that barely qualify as paths. They ford streams, climb volcanic slopes, navigate terrain that engineers said was impassable for vehicles. During island-hopping campaigns, Jeeps drive off landing craft onto coral beaches. The terrain shreds tires. Soldiers learn to carry multiple spares and repair flats constantly. Salt water corrodes electrical systems. Soldiers wrap connections in tar, coat exposed metal with grease, anything to slow the inevitable rust. In the Philippines, Jeeps become the primary transport for guerrilla forces. They're light enough to be manhandled across destroyed bridges, small enough to hide under jungle canopy, and simple enough for partisans with minimal mechanical knowledge to maintain. On Iwo Jima and Okinawa, Jeeps evacuate wounded men under fire. Stretchers are mounted on the hood and across the back. 4 wounded per Jeep, sometimes 5 or 6 when desperate. The vehicles race from aid stations to field hospitals, while Japanese artillery falls around them. Marines mount .50 caliber machine guns on Jeeps and use them for fire support. The combination, mobility plus firepower, allows small units to provide covering fire, then displace before counter-battery fire arrives. By the time Japan surrenders in August 1945, Jeeps are operating on dozens of Pacific islands. Some have been in continuous service since 1942, 3 years of jungle, humidity, salt water, coral, and combat. And many are still running. Over 50,000 Jeeps were shipped to the Soviet Union under the Lend-Lease program. Soviet forces appreciated them greatly. Russian terrain, vast distances, primitive roads, extreme cold should have destroyed the Jeeps. But Soviet soldiers discovered that the simple, rugged design thrived in harsh conditions. The Go Devil engine started reliably, in temperatures that killed more complex engines. The 4-wheel drive handled mud and snow that stopped Soviet trucks. Red Army commanders used Jeeps for reconnaissance, command vehicles, and artillery tractors. Soviet propaganda photos showed Jeeps with red stars painted on the hoods, racing across snowy steppes. After the war, the Soviets were so impressed that they copied the design almost exactly, creating the Gaz-67, which served in the Red Army for decades. American Bantam, the company that started it all, never received a full production contract for the standardized Jeep. They were awarded contracts to build trailers, thousands of them, including the quarter-ton trailer that became standard for towing behind Jeeps. But the vehicle itself, the machine born from Karl Probst's 49 days of desperate work, was produced by Willys and Ford. Bantam produced about 2,600 of their own BRC models before standardization. After that, trailers. The company survived the war on military contracts, but when peace came, so did the end. By 1956, American Bantam Car Company had ceased operations entirely. The factory in Butler closed, the workers dispersed. Karl Probst, the man who designed the first prototype in 5 days, received just $200 for his work. No royalties, no recognition during the war. It wasn't until decades later that historians would piece together his crucial role. Harold Christ, Bantam's chief engineer, watched as the vehicle his team had built in 49 days became one of the most iconic machines of the 20th century, built by other companies. The company that beat the impossible deadline, that delivered the first working prototype, that proved the concept could work, was written out of the story for decades. But the Jeep, their Jeep, would become legend. Let's talk about what 647,925 Jeeps actually means. If you lined up every Jeep produced during World War II, bumper to bumper, they would stretch for 1,625 miles, from New York City to Denver, Colorado. If you stacked them, you'd reach 246 miles high, past the edge of space. The total weight, 1.59 billion pounds, nearly 800,000 tons. The total horsepower, 38,875,500. Enough to move a battleship. The total number of parts, approximately 1.3 billion individual components. Every nut, bolt, spring, valve, wire, and gear. All manufactured, assembled, shipped, and put into service in less than 4 years. At peak production, the United States was producing more Jeeps per day than Germany produced Kübelwagens in a month. But numbers don't tell the real story. The real story is Lieutenant Audie Murphy standing in a burning Jeep-mounted tank destroyer manning a .50 caliber machine gun against German infantry at Holtzwihr, France. The action that would earn him the Medal of Honor. The real story is every medic who loaded wounded men onto a Jeep and raced toward a field hospital under fire, knowing the open vehicle offered no protection, but doing it anyway, because those men would die without immediate evacuation. The real story is Patton's Third Army racing across France in the summer of 1944, covering distances that shouldn't be possible, moving so fast the Germans couldn't establish defensive lines, and every unit had Jeeps for reconnaissance, supply, and communication. The real story is Soviet soldiers in the winter of 1944, driving Lend-Lease Jeeps through snow that stopped their own vehicles, pushing toward Berlin while the Go Devil engine kept firing at -40 degrees. The real story is British SAS raiders in the North African desert, bristling with mounted machine guns, appearing out of nowhere to destroy German airfields and disappearing before dawn. The real story is Marines on Iwo Jima, using Jeeps to string communication wire under Japanese fire, to haul ammunition to forward positions, to evacuate wounded from aid stations that regular ambulances couldn't reach. The real story is French resistance fighters in 1944, receiving Jeeps dropped by parachute, using them to harass German convoys and supply lines in the weeks before D-Day. The real story is every soldier who climbed into a Jeep and trusted it with his life, who loaded it beyond capacity and watched it keep going, who drove it through mud, sand, snow, water, and fire, and watched it survive. When the war ended, the army had hundreds of thousands of Jeeps scattered across the world. Many were sold as surplus. Farmers bought them for less than $200 and used them for decades. Some are still running on farms today, 80 years later. Others were left behind, buried in the Philippines, sunk in Pacific lagoons, abandoned in European forests. In the decades since, collectors have found them, restored them, brought them back to life. Willys continued producing civilian versions. The CJ series, civilian Jeep, became the foundation for an entire industry. Today, the Jeep brand is owned by Stellantis and sells millions of vehicles worldwide. Every single one traces its lineage back to that prototype delivered to Camp Holabird in September 1940. The design influenced vehicles worldwide: Britain's Land Rover, Japan's Toyota Land Cruiser, the Soviet Gaz-67. Dozens of militaries copied the concept. Small, rugged, go-anywhere vehicles with four-wheel drive and simple mechanics. But nothing quite captured what the original had. That combination of simplicity, durability, and versatility. 2,000 parts assembled into something greater than the sum of its components. In 1946, war correspondent Ernie Pyle wrote, "The Jeep does everything. It goes everywhere. It's as faithful as a dog, as strong as a mule, and as agile as a goat." He was right. But the Jeep was more than that. It was proof that when necessity demands it, when the timeline is impossible and the stakes are existential, American industry can produce miracles. 49 days from telegram to prototype. 3 years from concept to 600,000 vehicles. A machine that didn't exist in 1940 became, by 1945, as essential to the American military as rifles and rations. Karl Probst designed it in 5 days for $200. American Bantam built the first one in a factory that was dying. Willys provided the engine. Ford provided the production capacity. And soldiers, American, British, Soviet, French, Canadian, proved it could do everything the army asked and more. 2,000 parts, 90 seconds between vehicles, 647,925 total. The Jeep didn't win World War II by itself, but it helped. It hauled supplies, evacuated wounded, carried commanders, mounted weapons, towed artillery, ran communication wire, and went places that nothing else could go. It was the 2,000-part machine that won the war. And it started with one impossible deadline, one desperate company, and one man willing to try.